Hello and welcome to Circuitronics. I am Prashant Mishra and today in this video we are going to talk about an essential component of robotics, that is motors. Motors are widely used in robotics. Motors can be of different types based on type of current, DC motor or AC motor, based on use of brushes, brushless or brushed motors, based on time, synchronous or asynchronous motors. But the motor which we are going to talk about today is a very special motor. These motors are used in UAV industries, that is, these motors are used in remotely controlled drones. These motors are different from the other motors used in RC toys, that is, the brushless DC motor. A brushless DC motor or a BLDC is a synchronous motor powered by direct current via a switching power supply, or you can call it as electronic speed controller, that is, an ESC. An ESC provides three-phase alternating current to the motor based on the input provided by the user. Now I am going to show you the internals of a brushless DC motor. This is a A2212 model brushless motor which I have used in my previous quadcopter build. On the rotor of the motor, there are these permanent magnets inside the motor which are placed in an alternating fashion. On the starter, you can see these copper wirings. Let me explain you this. This is the starter, this is our armature, here goes the winding. Now let's add permanent magnets. Yes, there we go. So these are the three wires coming out of our BLDC motor for the input. To better understand the working, we need to analyze the output of our electronic speed controller. The electronic speed controller receives a PWM signal or pulse width modulated waveform as its input. The PWM signal must be between 1000 to 2000 microseconds. This can be considered as throttle to our motor, like 1000 microseconds corresponds to 0 throttle or 0 speed, and 2000 microseconds corresponds to full throttle or full speed, and so 1500 means half speed. Now the output of our ESC is a three-phase sine wave with each wave 60 degrees out of phase to each other. Now this output waveform works as an activator for the coils in the motor. Now look at this. Coil 1 is activated. It induces magnetic pole north and south. It repels north and moves next. As soon as it is at the next magnet or its next position, its poles have been reversed because of alternating input, and now it moves again. And so happens for the coil 2 and for coil 3 as well. And it happens again and again, and so the motors rotate. Now you may have understood how this motor is working. Now let's control it using Arduino Uno. Connect the circuit as given in the schematic here. Connect the red wire of the ESC to the +5 volts of Arduino, black to the ground, and white to the digital pin 9. Connect the ESC to the motor, and now open Arduino IDE in your computer. Download the sketch from the link in the description given below. We are going to use the servo library to control the motor, defining maximum and minimum for the motor, that is 2000 and 1000 respectively. Pin 9 is for the motor, pose is to store user input, creating object BLDC of servo. So starting serial with baud rate 9600. First we need to calibrate the ESC. To calibrate an ESC, set the throttle to full and then to 0. This can also be done using an RC remote. Now to control the speed of the motor, we are going to use the function write microseconds. It outputs a pulse width modulated signal on the pin attached to the Arduino, and so acts as the input for EAC. Now save, compile and then upload the sketch to your Arduino. And as you can see here, the motor is running. Also, to change the sense of rotation, just swap any two of the wires of EAC connected to the motors and it will change the sense of direction. The conclusion for brushless DC motors is that they have higher efficiency, higher reliability, lower acoustic noise, small in size and light in weight, greater dynamic response, better speed versus torque ratio, and higher speed range, longer life and lower maintenance. So that's it for the video guys. Thanks for watching. If you liked the video, hit the thumbs up. If disliked, you know what to do. Consider subscribing to the channel if you liked the content and comment below what you want to see in our next video. Thank you.